It's heavy, man. I wouldn't. I'll stick a newbie on him. Fuck, they'll be lost.
Well, I think that before anybody tries to formulate an argument, especially from a globe or a relativistic side, you'd probably do really well to go listen to Alan first, so you know what you're up against. You know, that's I try not to even engage in conversations with people. My prime example lately has been globers that think that the sky is some perspective and that's why it curves. There's no point in arguing with somebody that doesn't even know their own model. You know?
Yeah.
So, Alan, not for beginners, sure, but beginners should rise to that level before they make arguments.
Yeah, they won't, but you're right. But they won't. They'll just fucking.
Yeah.
Let me Google it. I know everything. I got Google it. I can AI it now, man. Shit.
And even that's not even right half the time.
Right? Yeah. Yeah, you got to spend hours at AI to get it to kind of come close, you know. You got to keep asking.
You know everything, is it, Flat Earth, dude?
What's that?
Did you say you know everything, did you?
Yeah. Yeah, I mean, I got a computer and a phone, man. I know everything.
Okay.
You know,
Where's the equator on Flat Earth?
You know I'm sarcastic, right? Okay.
Yeah. Where's the equator on Flat Earth?
There's no bendy water.
No, the equator. Where's the equator on Flat Earth?
I don't know, man. Seems to be in the center of wherever we live, man.
Center.
What is the equator? What's the equator, bud?
Maybe you should ask that question. What is the equator first, maybe?
Yeah, that's what I'm saying. What is it?
Yeah. What is the equator on Flat Earth?
Do you have one without the sky? That's my question.
Well, how do you get it with the sky?
I don't need one.
Same way you get it with the sky, bro.
How's that?
It's the equal point between our.
It's a beauty.
It's right there, man.
It's what?
It's a beauty. I don't know what that means.
I just mean the sky is beautiful.
Where the fuck is this coming from?
It's a beauty, man. What the hell is that?
So you could tell the surface by looking at the sky. Is that what you're saying?
No, I'm saying specifically you cannot. Interesting you put it that way, though.
So how is the equator derived on Flat Earth?
Why do we need to derive an equator?
It's at 0 degrees.
0 degrees of what?
The middle of the path of the sun throughout the seasons.
How do you define it then?
Well, the sun moves between two bands in the sky. Tropic of Cancer, the equator, and Tropic of Capricorn. The two bands being the two tropics. So the sun moves between them, and when it's halfway between them, that's the equator.
So that's two circles. Is that what you mean? Two centers of rotation you're talking about, isn't it?
I don't think so.
I wasn't really mentioning that. I was just saying, you were asking where the equator is. I was just saying it's directly on the ground. It's the point under where the sun is when the sun is at the equinox.
So you measure to the sun to get the equator. Is that what you're saying?
No, I'm just saying that's where the equator is. You can do that if you want to. The GP of the sun point. Yeah, you could if you want to do it that way.
Let's call it that.
Using Polaris.
Let's use the GP point, bro. The center.
GP center of what? GP point of what?
The sun.
Where's that? Where's the GP point of the sun?
We're in the fucking middle between the seasons. Come on, man. You're quit being
That's not how you derive latitudes, though, is it?
No, that all comes from Polaris.
Oh, okay. So that by measuring an angle to Polaris,
yep,
you derive latitudes.
That's how they did it. I didn't do it.
Is that how you derive the equator, from angles to Polaris?
No, I think they used the sun on that one.
Oh, go on. Tell me about that. Tell me about how that was derived.
I guess they could. I mean, you could use either one, the sun or Polaris.
Yeah. Well, tell me about the Polaris one. Describe that method.
Well, it goes, I'm at 32. If I keep going, I go down, to 0, where Polaris is on the horizon.
What do you mean when Polaris is on the horizon?
It's like vanishing, like setting. When it's setting, when it sets.
So what's the significance of Polaris and the angle? What you're measuring?
Well, we can no longer see it over there, apparently, and that's you guys came up with the globe, man, not me.
No, I'm asking about the flat Earth. I mean, how you derive the latitudes on flat Earth using Polaris.
I think everything works the same, man.
I mean, everything works the same.
Yep.
That's called a kinematic equivalence. Have you ever heard that before?
I'm just asking, about the relationship between Polaris and latitudes and the equator.
It's all exactly the same on either a globe or a flat model. It doesn't really matter. You can navigate successfully either way. It's a kinematic equivalence.
So the measurements are all the same? Is that what you're saying? They're the same?
Yeah, if you want to interpret it that way, the only difference being is that, when we use a flat baseline to create our angle, we're saying that flat baseline is actually flat, and then your model says, basically we interpret it as flat, but it's really curved. It's just locally flat,
So the circumference of the globe and the circumference of the equator on the circumference of the equator on the globe and the circumference of the equator on the flat Earth are the same distance.
When you use the sky, yeah, but the distances over water aren't really known. Like, we don't actually know those distances. Like, in relation to the sky, we understand it that way, but actually, as far as like stretching a tape measure across the ground, we don't really know.
So you have a measurement to the equator.
I mean, what you'd call the equator, yeah, because the sky is used as a navigation tool. Like, this is really important to understand the kinematic equivalence, and because otherwise people will be talking past each other about something there's no reason to argue about.
It's a physical place.
What is?
The equator.
No, it's derived from viewing the sky. So, I mean, the equator
ground
is
position. Ground position exists.
Yeah, but that ground position is based on you using the sky. You see, that's like a really fundamental understanding, is when you're talking about these kinds of distances and the shape of the Earth, like, you're just using the sky to interpret where you are on Earth. The optics of the sky don't prove the ground. It's not a proof.
I thought maybe you'd measure the Earth flat, so you have measurements.
Well, it certainly is. I mean, there's no measurement that shows the curve.
How did you measure it?
I can use examples. I mean, I guess optics, across the ground is yeah. I mean, I've been through these arguments, dude. I mean, I know which trees you're barking up here. I mean,
is that why you're trying to avoid answering? Is that what it is? You're worried about something?
Oh no, I like to give accurate answers. I'm not talking out of my ass.
Okay, so what's the accurate relationship between the elevation angle to Polaris and
60
the ground?
miles.
Who cares?
You're standing on the ground when you're making the angle, aren't you?
Yeah, and you use a flat baseline. You're using You're using plane trigonometry, bro.
So what's the relationship? Well, you're standing on the ground and you're measuring an angle to Polaris. Yep. You're on the ground, you're measuring an angle to Polaris, and what's the relationship then?
The curve necessitates gravity as interpreted through mass attracting mass or whatever, right? Or the other relativity or Einsteinian interpretation.
What's gravity got to do with this angle?
Well, I mean, there's no reason to necessitate go seeking a curve. The only reason you need to seek a curve is if you believe in that thing.
Whoa! I wasn't looking for a curve. Why did you bring a curve? I'm not looking for a curve. I was asking about the relationship between the angle to Polaris while you're standing on the ground, measuring an angle to Polaris.
69 miles.
And 69 miles, is it?
Per degree.
So so every degree you measure is 69 miles.
That's what they tell me, man. I haven't checked that myself. Okay. That's what I've been
told. It's a compounding formula. Like it's a parabola or something, I think, on a graph.
And I remember you, Ricksky, telling me that the circumference of the equator was 24,900 miles ish.
Okay.
Yeah,
dude.
Okay. So we do have a distance on the ground of the equator.
I've got no problem with saying that there is a distance. Okay. If it's 24
on the ground,
cool. Let's just go for it. It's 24. Let's do that. What's your next question?
That's on the ground.
Yes.
Yeah.
Sure. Why not?
Okay. So
maybe on the sea as well.
It's on the ground, and this is on the flat Earth.
It's on Earth.
Sure.
Right. So on the flat Earth, we have a equator. And the circumference is 24,900 miles. Does everybody agree with that, or?
I need to agree. You're asking me if you want to go fast.
Well,
yeah, no, but you might be the only person who think. You might be the only person who thinks that or knows that. I mean, what about you?
The
What
sun
about
moves 15
UFED?
degrees per hour, and you take that distance, the circumference of the Earth, and that's how fast it's actually moving.
Okay, so we've got 24,900 for an equator, and you've got, so you measure an angle standing on the ground. You measure an angle to Polaris, and let's say where's the range of the angles that you can measure?
The range of the angles.
Yes, we're using Polaris. I mean, you said there was a minimum somewhere. A minimum
Yes,
angle.
it's actually just like in from the equator, from what I understand.
So a minimum angle
So
and a
like
maximum angle.
89th, yeah, at the 89th, what is it? Latitude, longitude? Can't remember.
So there's 90 degrees. You're measuring a range of 90 degrees. Is that what you're saying?
Well, that the like, what is it? When you get to the equator, the Polaris has basically disappeared.
Yeah, but you're measuring a range of angles from when Polaris is at its zenith, with its ground position at the North Pole. Is that where its ground position is?
Supposedly.
Yep.
Okay, so we got when it's at 90, and you measure a 1 degree angle, and you move away from it, and you measure another angle, you travel 69 miles, right?
Correct.
Okay, so you and you can do that for 90 1 degree measurements. Is that true?
Yep.
To reach the equator. 90 1 degree measurements. Okay.
We could get this off ChatGPT or anywhere on the internet. I'm joking, but
okay,
okay.
Well, I'm just running through it. So 69 miles is a distance from the North Pole to the equator. I've heard you say it before, Gio. What was the number you put to it?
Like a dog on a leash, and you're just yanking the leash around. Can you tell us the destination? Are we going to a park somewhere where I can go fetch or something, or where are you taking?
Don't worry, Rixky. Don't worry. So you have a distance from the North Pole to the equator. 90 multiplied by 69. What's that number?
You don't have that? 6210. 6210. I think we've
6210. So from the North Pole.
We've talked about this at least 30 times. That you've asked the same thing.
So from the North Pole to the equator, we have 6,210 miles, and we have a circumference of 24,900 miles. What's the value of pi on flat Earth?
You feeling Groundhog Day, Gio?
Right? 100%.
Are you good at maths then, Rixky?
You asked me this question. Gio gave you an answer before. You said that's right. So apparently you already know the answer. You're just asking me for what.
No, I'm
6210. I haven't been to the North Pole. I haven't been to the North Pole, nor have I measured every degree of 69 throughout the entire spectrum from 0 to 90 on both sides of the equator. So I haven't done that. The 6210 number, it is the 90 degrees times 69 miles. It also is the distance the mainstream model claims as the distance from the equator on the ground to the North Pole on the globe.
Okay,
that's what they claim.
Like, you could call that a radius, couldn't you?
Not really on a globe. I mean, not from
the flat Earth. On the flat Earth, you could call it a radius, really.
Call it a distance, man.
Yeah, radius. It's a linear distance, isn't it? It's a linear distance from the North Pole to the equator of 6,210 miles, which gives you a circumference of the equator on the flat Earth of 24,900 miles. Yeah.
Its circumference is not a good term.
Okay.
Well, Rixky.
Yeah, I'm not saying that, but sounds like you're saying
hang on. Rixky said it was a circumference of 24,900 miles. I did ask if anybody else agreed, or he said it wasn't necessary. Nobody else chipped in.
Sure, I'm happy with the figure. I don't are we going back to square one again?
Yeah, that's why I'm asking you. What do you have a different value for pi on flat Earth?
I don't believe so. I mean, 3.14, but I mean, I can't explain the interpretation of circles, but pi is not the only way to think about circles.
This guy troll.
You derive the circumference from the radius. Is that not true?
Yeah, sure.
Okay, so we have a radius of 6,210 miles. So how do we get the circumference again? What's the maths?
If you're talking about a 24,901 mile circumference flat circle, then the radius to the center of that is 3959. The radius they claim the globe is.
You've got 6,210 on the flat Earth, though.
I don't have got anything. I never defended or said anything about a flat Earth
ever.
Said
it, though. You said it was a radius.
No, I did not.
You said from the North Pole. You did. You just
I was
said
asking your tedious. I was
answering
your tedious questions. I was answering your tedious questions, and I was telling you what those numbers are, and also what the globe claims. You're wanting to attach.
Told me what they were, Gio. You told me it was 6,210 a couple of weeks ago. Rixky told me the circumference is 24,900, and you just said the radius was from the North Pole to the equator, 90 times 69, a linear distance. That's how you travel on the flat Earth. 1 degree is 69 miles, a linear distance, a flat Earth distance.
Dude,
Okay, then I'm gonna make this
radius.
really. I'm gonna make this really clear. Then, when you use the word flat Earth, that could mean multiple things. For example, the word flat Earth could mean a planar surface that is stationary potentially, and as well. So you have planar is the foundation of it, and then that's it, just planar and stationary. That term flat Earth could be used for that. Or hold on, let me finish. Or the term flat Earth could be used for fill in the blank. Maybe you have a Gleason's map in your mind. You might have circumferences and radiuses and circles, and you may have some whatever you have going on, and then you're labeling that flat Earth and trying to pin people on that. So I'll just be very clear. I'm not defending whatever model you think that you're trying to put forth. I'm responding to the questions you're asking in terms of no, I did not state. You're a very disingenuous person. We're going to mute you and move on. Hold on, unless you're going to stop trolling and doing this, we're going to mute you and move on. This is very insidious and bizarre. You're just doing straw mans and you're just trolling. You're not being genuine. You're being disingenuous and you're doing some kind of bizarre bad faith thing, and it's very unpleasant. It's not actually promoting to a positive conversation. So if you want to stop and actually get back, you're answering questions and then doing straw mans, then expecting people to defend your straw mans while you're playing a game. It's very clear to see what you're doing. So either discontinue that and move forward, or we're going to move forward with a better conversation.
Well, I understand it may be unpleasant for you, but we're talking about geometry, aren't we?
Well, we got measurements.
What's the point of throwing a whole bunch of...
Hold on. I didn't say it was unpleasant for me. That's gaslighting. I didn't say it was unpleasant for me. You're being a disingenuous character who is it's not a pleasurable conversation. We were having great conversation for hours. Now we're dealing with a sociopath. So either stop being a sociopath and playing games and have a real conversation, or just mute yourself and we're going to move on to something better.
Wow, that's amazing, Gio. Wow.
It may be amazing.
Everybody here has
go ahead. Say something of content.
Everybody here has said they're flat Earth measurements. It's stated
everywhere.
Nobody said that once. Dude. Nobody said that.
1 degree is 69 miles. That's a flat Earth measurement. Everybody says it. 1 degree equals 69 linear miles from the North Pole to the equator.
What's the point of actually throwing all these geometric sort of questions that, that I haven't got a piece of paper and writing out these figures and forming the equation. So what's the point of this?
And you're just going to interrupt people, and you're going to interrupt as well, dude. Please stop. Now you're interrupting. Go ahead, Tarek.
But it's just get to the nut and bolts of it, because as I said before, man, you're just jerking a lead all over the place, asking sort of leading questions, right? And then they're all complicated math questions. I got a bunch of numbers rolling around in my head and equations, and you want me to add pi in somewhere? I just what are you trying to lead to? What are you trying to reveal that I don't know what the exact mileage or the distances are around the equator? What are you actually trying to reveal in your questioning?
Rixky, are you saying that to derive the circumference of a circle from its radius is a complicated geometric question for you?
Divide a circumference by its radius. No, it's not complicated, dude. If I got a piece of paper in front of you, we're having a dialogue, a conversation, and you're trying to add math.
That's what I was, but Gio got upset about me asking the question.
Well, you did just answer his question with another answer, though. You didn't answer his question.
It's just a very strange game of you're asking questions based on some foundational things, like just distances, numbers, and miles, and then you're trying to attach it to some kind of straw man model, which it seems like you're trying to corner someone, but you're not really cornering anyone. We're just trying to have a more productive conversation. So can we just have it be more productive? If there's a statement you'd like to make, maybe put a point on the table, ask a question, do something that we can move forward in the conversation that is of substance.
Right, like the last guy asked.
It was a geometric question. That was the question. It's geometric. I mean, it's not complicated, is it?
Hold on a sec. You were asked a question what is your point? Where is your questioning leading to? What do you want to discover from us?
Well, I'm not discovering anything. I'm just trying to work out myself how this geometry works. Now, somebody says to me that by measuring, if somebody says to me that they're measuring 1 degree angle to Polaris, and if they move away where it measures another degree, a less degree or more degree, that you've traveled 69 miles in a linear distance, measured on the ground. Flat ground. It has to be flat ground because you can't get the angle apparently without a flat ground. So we've traveled 69 miles. And between the equator and the North Pole, there's 90 degrees. And 90 multiplied by 69 degrees, there's 69 miles. And on the ground is 6,210 miles, as Gio has confirmed.
Great. Cool.
And the circumference of the equator is said to be the same as the circumference about geometry, don't we?
Is it?
Please.
Go over to Nathan Oakley's, bro. Come on.
Yeah, I'm sure he'll want to talk to you.
And then say, celestial navigation.
Not true. The flight data shows
a linear distance.
Yes. Yeah, that is the claim.
Okay.
And much. Yeah, you have a straight line.
Also, the map. Surely, I mean, if you want the whole map,
climate change. Where's all the heat? Where's all the
oh yeah, you can grow your own tiny little herbs and